Hello class. Today I will be talking to you about nebulae. What are they? How are they formed? And what is their purpose in the creation of stars and planets? The word nebula comes from the Latin for cloud. A nebula is just that, a cloud of cosmic dust and gas floating in space. More than one nebula is referred to as nebulae. The earliest use of the word in the English language comes from the late 1600s when doctors would refer to either cloudy formations in urine or a cloudy film on the eye that resulted in vision problems. It was first applied to interstellar clouds of gas and dust in the early 1700s. In fact, the word nebula was applied to any celestial object which appeared cloud-like when viewed through a telescope. Back when telescopes were not as powerful as they are today, our nearest neighboring galaxy, Andromeda, was often referred to as the Andromeda Nebula. We now know that galaxies are not cloud-like, but instead made up of billions of stars. The word nebula is now reserved for genuine interstellar clouds located within galaxies. These clouds are the foundation of the universe as they contain all the elements necessary from which stars and solar systems are created, while also being visually astonishing to look at. The stars inside these clouds cause them to glow with rich colors and bewildering light. The colors that you can see are the result of different elements residing within the nebula. Typically, nebulae are composed of about 90% hydrogen, 10% helium, and 0.1% heavy elements such as carbon, nitrogen, magnesium, potassium, calcium, and iron. Nebulae are among the largest objects in the universe, with many of them being hundreds, sometimes even thousands of light years across. Nebulae can be divided into 5 major categories. These are emission nebulae, reflection nebulae, dark nebulae, planetary nebulae, and supernova remnants. An emission nebula is a cloud of superheated gas. Within these nebulae, typically a single star illuminates the molecules in the cloud with ultraviolet radiation. As these atoms revert to a low-energy state, they emit high levels of radiation. This causes the nebula to glow. Typically, emission nebulae are red in color because of the high concentration of hydrogen in the cloud. However, they can appear blue, green, and many other colors. Reflection nebulae differ from emission nebulae in that they do not emit their own radiation. They are clouds of dust and gas that reflect the light from nearby stars. Reflection nebulae tend to be blue in color because of the way the clouds scatter the light, with blue light being scattered more efficiently. A dark nebula is a cloud of dust that blocks the light from objects behind them. They are very similar to reflection nebulae, but differ in the position of their light source. Dark nebulae typically are seen adjacent to emission and reflection nebulae. The Horsehead Nebula is arguably the most famous of the dark nebulae. It is easy to see why. Planetary nebulae are shells of gas produced by stars that are nearing the end of their life cycle. The name is often misleading, as they have nothing to do with planets. These nebulae are called so because of their round shape resembling planets. The outer shell of gas is typically illuminated by the remains of a star at its center. Supernova remnants are created when a star reaches the end of its life in a massive explosion. This explosion expels the outer shell of the star into space, creating a cloud of matter that glows with the remains of the star that created it. The Crab Nebula is arguably the most famous and recognizable nebula that we have photographed. Nebulae are often regarded as stellar nurseries for the role they play in the life cycle of stars, both at their birth and their death. Stars are born in clumps of gas, dust, and other materials inside emission nebulae. Often a nebula will lie in wait for billions of years, waiting for the right conditions to create stars. Eventually, gravity condenses the matter into clumps that grow in size as they gain mass. As the gravitational force increases, these clumps of matter begin to form protostars, whose core temperature reaches upwards of 18 million degrees centigrade. At this point, a star is born. This new star will eventually explode in a supernova, thus creating a new nebula, and then the cycle repeats. The Hubble Space Telescope has captured some truly spectacular images of nebulae since it was launched into orbit in 1990. More recently, the James Webb Telescope has captured a number of images that give us an even clearer look at these magnificent celestial bodies. This is the Carina Nebula, a massive star-forming region of the constellation Carina, located in the Milky Way galaxy. This nebula is noteworthy for its supermassive stars that are estimated to be approximately 50 to 100 times bigger than our own Sun. The James Webb Telescope captured this image in early July. This is the Tarantula Nebula, captured in early September by the James Webb Telescope's near-infrared camera. This nebula is home to some of the hottest and most massive stars ever discovered, as well as being the largest and brightest star-forming region in the local group where the Milky Way galaxy is located. This is also the Tarantula Nebula, but viewed using the Webb Telescope's mid-infrared camera. This type of imaging technique pierces through the thick veil of gas and dust and shows us a previously unseen cosmic environment. Thank you for joining me today as we journeyed through the universe, studying the various types of nebulae and the role these celestial bodies play in the creation and destruction of stars.